Hey guys, Buildzoid here, and we're back with the 14900K on the Gigabyte Z790 Aorus Master X motherboard. In the previous video, I showed you how you can block the CPU from sending ridiculous VID requests to the motherboard. Today we're going to be taking a look at getting some more performance out of the CPU without turning off any safety features, and still having the VID locked down to like less than 1.4 volts. So let's get into it. So I am on the F7 BIOS, right? And with the F7 BIOS, we of course have the Intel default settings. We're not going to be turning those off. That's kind of the whole point of this to me, is like get as much performance back without, doing what without just turning off all of the safety features. Or yeah, well, mostly just not turning off the safety features, because technically one of the things I'm showing you here today can negatively impact stability. Also, because we don't have the VID limit turned on, the CPU has already managed to send a VID request for over 1.5 volts. You know what's funny? In an earlier take of this video, I actually had this hit all the way up to 1.61. It's just that but partway through that take, I made a mistake, so it was just got scrapped. Anyway, so what we're going to do now is we're going to first of all turn on the VID limiting. So we're going to go into Intel VR control. We're going to turn this on, and we're just going to set a 1400 millivolt VID limit because I don't know if anything higher, I'm not even sure that 1.4 is safe, but it's definitely safer than the 1.5 that you get on a lot of i9s right out of the box. So, yeah, now the problem if you just do this VID limit is that you basically lose your 6 gigahertz boost unless you have like a top 1% CPU. Because, yeah, most i9s, as far as I know, have VIDs somewhere between 1.45 and 1.5 volts for 6 gigahertz boost. So, yeah, if you set a VID limit of like 1.4 volts, yeah, you're never going to see 6 gigahertz boost. So, anyway, the next thing we're going to do is we're going to set the load line calibration to high. And now that we've set the load line calibration to high, we can actually lower the AC/DC load line settings a bit. So we're going to set these both to 55. And the reason I'm setting these to 55 is from past testing, from some other testing that I've done, I've figured out that this motherboard has the stock, the V droop on the voltage regulator is set to 1.1 milliohms. When you set the vCore load line calibration to high, that basically applies a 0.5 multiplier to the stock, to the load line setting of the VRM. So 1.1 times 0.5 is 0.55. And that's why we punch in 55, because basically what the AC/DC load line settings are doing is they're telling the CPU what the VRM load line is. They don't actually, well, the AC load line is at, I'll have another video explaining what the AC load line does, but yeah, these don't directly control, these kind of don't directly control the voltage regulator. They're basically just informing the CPU about what the motherboard is going to do. And then the CPU adjusts its VID requests based on those expectations. So yeah, so we're going to do that. And that's all we're going to do in this part of the BIOS. And now we're going to set our CPU vCore. Oh wait, nope, that's the wrong menu. We're going to set vCore voltage mode to adaptive. And we can actually leave this in legacy or selection, and quite frankly, legacy is fine. And now you can actually do negative voltage offsets. That's not a problem. Now, the thing is, if you used auto and then you go dynamic vid and you set minus 0.1, this doesn't work if you have Intel default settings turned on, because the Intel default settings enable CEP. And basically CEP gets very upset if the voltage that the motherboard is sending to the CPU doesn't match the VID and expected voltage that what the CPU is expecting. So if we have a load line of 0.55 milliohms AC load line set to 0.55 milliohms, and then we set this negative voltage offset, which this negative voltage offset here, this isn't getting applied to the VID request, this is getting applied to the voltage regulator. So basically the CPU will send off a VID request where it's like, hey, I want 1.3 volts, you know, the CPU expects to see that voltage to droop by 0.55 milliohms. So if we're pulling, say, 200 amps, that voltage is, okay, I'm going to simplify this for myself. Let's say 0.5, okay? For convenience, 0.5. It's actually 0.55, but for convenience, 0.5. So at 200 amps, the CPU, you know, requests 1.3 volts, and it expects to get 1.2 volts. But if you set this dynamic V-core to minus 0.1, the voltage regulator gets that 1.3 volts, subtracts the V-droop due to the 200 amps of output current, and then it also adds this negative 0.1 volt offset on top of that. So that's another 100 millivolts getting removed, and that's what it actually sends to the CPU. And when the CPU gets that, it gets very upset because it was expecting 1.2 volts and it's only getting like 1.1. So if that happens, the CPU will start clock stretching and you lose a bunch of performance. So that's why we're switching the V-core voltage mode to adaptive V-core, and then you can actually leave it in legacy or selection. That doesn't matter because either of these actually gets applied directly to the VID. Now with selection, you do get finer control, like you can set a different voltage offset for your like 6 gigahertz boost and your, you know, 5.8, 5.6, that kind of thing. And like ultimately it just makes the tuning process take a lot longer and your stress testing is potentially going to get more annoying. So personally, I would probably just use legacy if I was setting this up for my daily system, because while I do like overclocking, I also don't like spending, like, you know, I like using my daily system, not fixing my daily system. So anyway, now in terms of what kind of negative voltage offsets you can expect, oh, and like once you're in legacy mode, you just use the internal CPU V-core offset. Also, if you want to navigate this drop down faster, instead of just using the arrow keys, you can use page up, page down to like skip through it a lot more quickly. So anyway, I would expect that most CPUs should be able to run something between minus 0.05 and minus 0.015. And I'm basing that off of the fact that motherboard manufacturers have been shipping Z790 motherboards with that as a, like basically a default undervolt through misconfigured AC load line settings. So yeah, which is also why the motherboards were disabling CEP right out of the box. If you get really lucky, you might get a CPU that might be able to run something like minus 170 or something, but I kind of doubt it. So like I already tested this CPU a bit, so I kind of have a rough idea of where it starts to really have problems. But if I didn't know the CPU better, I would probably just start at 0.1, like 0. minus 1. I mean, minus 0.1. And go from there. All right, and I'm going to show you what happens if you like set the voltage too low as well. So anyway, I'm going to clear the oscilloscope monitoring now, so that you'll see like the max voltage in this configuration is just not going to go. It's going to actually go a little bit over 1.4 because the AC load line adjustment that I made does lead to some extra overshoot. So we're probably going to see something like 1.42-ish or something instead of like if we left the AC/DC load line and the VRM load line alone and at like 1.1 and 90, we wouldn't see any overshoot. But there is a slight performance benefit to setting the AC load line lower, especially for low loads, because the way the AC load line works is it basically gets added as like a positive voltage offset. And if you have the VID limiting turned on, basically what happens is the CPU goes like, hey, I think I need this voltage that is above the VID limit to run this frequency. And then it just, then, you know, it checks the VID limit and goes like, okay, I'm actually just not going to run that frequency. You do like from a performance perspective, you want the AC load line to be as low as possible. From like everything else, but there are like negative consequences to doing that. So I'm trying to balance that. Like, I'm not entirely certain that you would actually have massive, like, issues if you set the AC load line to, say, 0.2 and the like, the VRM load line calibration to extreme. Actually, for extreme, it should be, like, 0.15 on the AC load line. But, yeah, so I'm not 100% certain if that would be massively unreliable. But, or like if it could cause degradation or something, but I'm erring on the side of caution. And with 0.55 and high LLC, this, like, to me looks good, for whatever that's worth. So anyway, so we're just going to hit this with Cinebench to see what kind of, like, all-core performance we're getting. Also, in this configuration, we do actually have the 6 gigahertz boost, which I'll show you. So yeah, we're up at like 39,735 points. For comparison, the, like, gigabyte configuration on this motherboard, like the gigabyte, like, if I disable the Intel defaults and we just use the gigabyte CPU configuration, which removes the power limits, removes the current limit, drops the AC load line to 0.4 while maintaining the stock VRM VDroop, which is why the, like, default configuration with the CPU is completely unstable. You can't run Cinebench R15 at all, because there's, like, a massive undervolt just right out of the box. Actually, I did the math on that, and that undervolt that Gigabyte ships this motherboard with works out to about minus 200 millivolts-ish. Something like that, which is ridiculous. Like, that's insane. Like, honestly, I'm surprised that even boots. But, yeah, anyway. Yeah, and so that configuration from Gigabyte scores a little bit over 40,000 points. The Intel default profile tends to score somewhere between, like, 37.5 and, like, 38,000 points with my CPU. The score you actually get in Cinebench does vary with silicon quality a bit, because if you have a really, like, you can get CPUs that have very high VID voltages, very low VID voltages. Funnily enough, that doesn't directly correlate to the like, resulting power consumption, because sometimes you'll get CPUs that have, like, very low VIDs and still kind of insane power draw, and sometimes you'll get CPUs with very high VIDs and relatively low power draw relative to the, like, VID voltages that they have. So yeah, like, there's a lot of variance in silicon. Like, it's not always like, oh, this silicon has a high VID, therefore it is good or it is bad. It's like, and also the VID tables aren't always consistent in how much margin they have. So, like, you can get some very low VID CPUs with very little margin for undervolting, and then you can get some very high VID CPUs with a lot of margin for undervolting. So yeah, it's kind of all over the place. So your results will vary. It's not even may vary. They're going to be different. But you should be able to get somewhere in the range of, like, 40,000 points, I think, with just applying a basic undervolt. Now, for stress testing these undervolts, Cinebench R15 is, like, weirdly good. The extreme version is somewhat better. And the reason, and I don't know exactly why this is, because if you actually look at, like, the power consumption and temperatures that the different Cinebench versions run at, they're actually kind of the same. But for whatever reason, Cinebench R15 is the first thing to crash, in my experience, with if, like, you undervolt too much. So yeah, now minus 100 on this, minus 100 millivolts on this CPU is just fine. So yeah, R15 still runs. And I can't close it right now, but yeah, so that runs. There are other stress tests you can use, like there's Y-Cruncher, though funnily enough, my CPU actually is more stable in Y-Cruncher usually than it is in Cinebench 15, which is bizarre, but it's a thing that I've run into. Like, I didn't I didn't know that the default gigabyte settings on this motherboard are unstable for, like, for a very long time, because basically the first thing I started testing this motherboard with was Y-Cruncher. And like the configuration of Y-Cruncher I was using wasn't triggering any stability issues. Cinebench R20 and 23 were fine. And then somebody told me, hey, you should try R15, and R15 just crashed instantly. Or in like two loops. So yeah, like it's you like when you're doing this, when you're lowering the voltage, you're gonna kind of wanna run like a variety of different software to see if the stability is getting worse. Man, you know what really annoys me is that like on any other field in the BIOS, okay, that's not true, but on most other fields in the BIOS, if you press the minus, wait, did they change that? Okay, this should work. Yeah, if you press the minus button, it just like, increment, or the plus button, it just increments the value up and down. Doesn't work here. Doesn't work for the offset values. Anyway, so previously we tried minus 120, so now we're going to try, like, intentionally something too low. We're going to go to, like, minus, let's try, like, minus 170, minus 175. That should be right on edge for this CPU in terms of stability. We might actually start seeing things like what I find really, what I find kind of interesting with 13th gen, 14th gen is when you're on the edge in terms of voltage, you start getting things like the Windows boot up sequence takes really long sometimes, which I ran into in like pre-testing for this video. I tried, I think, minus 180 or something. And basically I got stuck with the black screen that you get before the Windows login. Like I got stuck on that for like forever. I thought the system crashed, but I have the oscilloscope, so I saw that it was like still going through the power states. And what I mean by that is like if we're not doing anything, you can see how like the CPU like, cycle, like it changes the voltage depending on what it's doing. And so I could still see that like the CPU was still sending commands to the VRM, so it wasn't hard locked, because if the CPU locks up completely, nothing happens. So it was still doing stuff, but it was just taking forever because the voltage was too low. Anyway, so right now we should be on edge where it's like, I think R23 will run, and we should see over 40,000 points at this point. Oh, I guess it won't. So, okay, we're actually below. Yeah, so if you end up with this, then you've just set the voltage too low. If you set it really, really low, you might not be able to post. So, so yeah, so this is what, like, this is the kind of behavior you'll get if you, like, set your voltages too low. So we're gonna go to, like, say, yeah, minus 1.54. I mean, 0.154. What would be, like, if it was in millivolts, I could say minus 154. Like, it technically is millivolts, right? It's a minus 154 millivolts. But in the BIOS, it displays as 0.154 volts. So, yeah, and like the less negative offset you run, the less of a like the less the score goes up, but obviously the system's more stable, because that's like the thing is like there's a balancing act to this, right? Where the more you lower the voltage offset, the more performance you get, but the more like at some point it's gonna not be stable anymore, and it's not gonna be unstable for all workloads equally. Is the thing you have to keep in mind. So if you're primarily if your system is primarily a gaming system, you know, like, and you don't care about the system like randomly crashing too much, then you can be pretty brave with this, I think, unless you're playing something competitive and you really can't afford to crash out of the middle of a match or something. But if your 14900K is like a workstation setup, you probably don't. Like if you run into crashing at like say minus 150 or something, I would probably not run anything less than minus 100. Right? Like if the crashing gets like if the instability gets really bad at minus 150, then you probably don't want to go below minus 100. This should run, I think. Yeah, it does. Though I'm not sure with this setting if we're going to be able to run R15. Well, actually, if the score is over 40,000, I think R15 won't run anymore. And yeah, this is actually higher than what the default gigabyte profile gets. And the gigabyte default profile for this motherboard turns off the power limits. Like we're still on that power limit. Though with this offset, like I can pretty much guarantee that if we try to run Cinebench 15, this is just going to crash. But yeah, like we're on the stock power limit. We're getting like 5.5, 5.4 boost. Temperatures are amazing because like we're just riding that 253 watt power limit, right? Because we're still using all the Intel defaults. Right, and like now that I've run hardware info, the score's lower because the sensor monitoring gets in the way. But yeah, I think in this setup, this is actually not going to be stable. Or is it? This is running for a surprisingly long amount of time. The funny thing is, like, your CPU's stability actually gets better the lower the operating temperature is. Which is probably why, like, with the power limit in place and the current limit in place and all of the safety feature, like, and the VID limit in place, like, with all of these limits applied to the CPU, I am still able to, like, match the performance that the motherboard gets with no limits whatsoever. And mind you, the motherboard on, like, the Gigabyte profile, like, it's still undervolting the CPU. Which I do find kind of funny, how, like, no limits, unstable undervolt, and yet it, like, doesn't even outscore this. Huh. I'm still not convinced that this is not gonna crash, though. It might just take a while. Like that's the thing is like if you're doing any kind of overclocking like well, if you're doing any kind of undervolting like this, you can't just assume because it didn't crash one run of Cinebench that it's going to be perfectly stable. This is way more stable than I think it should be. I am very. I mean, I guess we could just try the like Y cruncher the benchmark. Did that crash? Okay, I think this is crashing. Yeah, so you do need to like check with a bunch of different workloads. Yep, that doesn't look like it's working. I'm gonna try the other version. Maybe there's like something misconfigured about the OS. Okay, maybe I broke that Y cruncher install. Might not be instability. It might just be like broken. Like I did something to the program. I am still surprised that this is so stable and fast. Like I really didn't think we'd be able to get to 40,000 points in Cinebench without this also like being really really unstable, but well, it isn't. So yeah, that's neat. Guess for sanity check, we could briefly try what happens if I load up the gigabyte settings. So I did just shut down the system, so we're going to quickly clear CMOS. Because, yeah, I think the gigabyte settings on this motherboard are like 40,000 points. But anyway, at this point, you know, you get the idea, right? Turn on the vid limit. If you're on a gigabyte, like, the gigabyte boards all have basically the same voltage regulation. So the, like, high LLC 0.55 load line setup that I'm using, you should be able to use... Yeah, you should be able to use that on basically any Gigabyte Z790 motherboard. At least the, like, north of $200 in price. I don't know if they have some, like, super low-end board with, like, a garbage VRM. But anything with a good VRM, you should be able to basically use the load line settings that I'm using here. And anyway, so we're back in the BIOS, and we're just going to disable the Intel profile. Because I did just clear CMOS. And we're going to see how Gigabyte's optimization does compared to my optimizations. I have low expectations for this. Well, I mean, in terms of scores, I imagine it'll be pretty good. In terms of temperatures, it's going to be horrendous. In terms of voltages, it's going to be horrendous. In terms of stability, it shouldn't be able to run Cinebench 15 anymore. I'm actually going to reset the oscilloscope. Because the Intel default profile does actually run quite high voltages, because it sets the AC load line to 0.9. And there isn't, like, a vid limiter turned on. Now, the default, like, the Gigabyte profile should set the power limit to, like, 280. I kind of wonder how this would interact with a 14900 KS. Oh, and we're already over 1.5 volts, and we didn't even make it into Windows yet. So I'm actually, like, I want to check the load line the load line settings on the CPU, because I already know what they are for the motherboard. The motherboard's currently set to 1.1 milliohms. But the CPU is set to 0.4, yeah. So if, like, so this is, like, this 0.4, 0.9 thing that Gigabyte is doing, that's why they turn off CEP for their, like, default configuration of the CPU. Also, if we check the power limit, you will notice that it's now 280 watts for long term, and for short term, it's 4,000 watts. So the temperatures are going to be absolutely insane. Also, the current limit is completely turned off. CEP is turned off. Everything's turned off. Well, I mean, like, they didn't turn off the long-term power limit. Yeah, so we're going to see how, like, Gigabyte's unlocked profile compares to, like, my very locked down profile. Oh, it didn't even manage to finish Cinebench R23. See, the plan was it was supposed to be able to run that one, and then I'd run 15, and 15 would crash. But I guess we're not even going to get to doing that. I wonder if the CPU managed to degrade and all, like some more since like I've last run the Gigabyte settings. Or it's just random, because it did technically sometimes crash running Cinebench 23. It just wasn't super common. Anyway, the temperatures right now are insane. And it will actually just not run 23. Will it run 20? Like, did they change something? Because, like, on the F5 BIOS, I was able to run 23. It wasn't good. It was, like, well, I mean, it ran, and it would score, like, 40,000 points. Let's see if I can run 20, if I can't run 23. But there shouldn't be a difference. Like, if 23 is crashing, I can't see any reason why 20 would run. Yeah, no, 20 doesn't run either at this point. So it's managed to get worse. Like, I used to be able to at least run 23, but now I can't even do that. Well, that's fun. So I guess we don't, so basically at this point, we don't even have to so I guess you could say the Gigabyte default settings get a score of 0. So my score is infinitely better than Gigabyte's score. Because Gigabyte can't even get the damn test to finish. So, yay. Which is kind of concerning because I used to be able to run that. And it's not like I've racked up a bunch of hours of extra runtime on the CPU since I last ran Cinebench R23. I wonder if something in the BIOS changed. I mean, I can fix the instability temporarily with... Like, now I'm, like... Kind of, yeah, now I'm kind of tempted to go back to, like, F5 and check if F5 can run R23. Because F5 couldn't run 15, but it did run 23. So the fact that, like, now I can't even run 23 is slightly concerning. Unless... maybe they changed the VRM load line? Because that's actually really hard to check. Like, that's actually... That is really, really hard to check on most motherboards. Anyway, so the way I'm going to fix this, I'm just going to set this to 55, which is going to lead to... well... yeah, even higher voltages. But at least it should stop crashing long enough to finish 23 and we can get a score. Funnily enough, 55 used to be the default setting for Asus motherboards. Is it 50 or 0.5? I think it was 55 default for Asus boards. And they were doing the same thing, like the VRM would be set to like 1.1 milliohms and then the AC load line for the CPU would be set to 0.55. And if you and if your CPU wasn't like lucky enough in terms of silicon quality, that would cause your CPU to crash even if it was brand new. So before it even degraded at all. So this should run 23, but of course, like the temperatures are going to be insane. The voltages are insane. Like we can see that from the oscilloscope that the voltages are insane. I am actually slightly concerned that the Gigabyte settings can no longer run 23. Man, those vids are horrifying. Oh, we managed to run the test long enough to actually hit the power limit this time. And yeah, it's like 40,000 points. So, yeah. Like, anyway, so now you can see that even if you have all of the Intel, safety features turned on, and actually more than even what Intel mandates, right? Because the VR limit thing that I'm doing, that's not like standard from Intel. So you can have like lower max voltages, lower temperatures, actually have a power limit, have a current limit, have CEP turned on, and still get basically the same scores as if your motherboard turned off all the limits. Now, technically, if you like, I imagine if like the Intel profile that I'm working with, like if we bump the power limit a bit, there might be a little bit more performance that could be squeezed out of the CPU. But I don't like I'm not like you could. The thing is, if you have the Intel default settings turned on, it actually stops you from like changing certain settings in the BIOS. So you would basically have to turn on all of this. Like, so if you wanted to like do a completely custom mix, and man, the CPU is actually okay. We're just gonna turn it off. I'm not a big fan of seeing it randomly spike to 1.6 volts. But yeah, so if you use the like Like, the thing is, if you turn off the Intel defaults and you want to reapply all of the, like, stuff that the Intel defaults do, just with, like, slightly higher power limits and slightly higher current limit or something, like, say you wanted to use the 14900KS power configuration on your 14900K, it's kind of a pain to do that. Because, like, it's a lot of different settings in the BIOS that you have to... Well, yeah, it's kind of a lot of different settings that you have to go through. Yeah, like, you can totally run the Intel defaults and just, like, enable a VID limit and then undervolt the CPU anyway and have CEP turned on. You don't lose performance. Obviously, if you undervolt too much, it's going to be unstable, but you can, use undervolting with all of the limits in place to basically get back to the performance level of the incredibly questionable default motherboard configurations that used to be, like, well, were standard for LGA 1700. So yeah, hopefully this is somewhat helpful. Also, I don't understand how these videos always end up this long. I mean, I did get kind of distracted by trying to fix Gigabyte's profile. Anyway, so yeah, hopefully you found this somewhat interesting and helpful, and that's it for the video. So thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There is a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, hoodies, posters, the usual YouTuber merch, and I've also got a Bandcamp if for some reason you want to abuse your ears. There's a link to that down in the description below as well. That's it for the video, so thank you for watching, and goodbye.